Welcome back to Educator. Next we're going to be talking about a reaction called a free radical halogenation. This is a reaction of alkanes, and as the name implies, we're going to be doing a halogenation reaction. We're going to be adding a halogen to the alkane structure. So here we have a very simple alkane such as methane. We're reacting with chlorine, Cl2, and this reaction is going to happen in the presence of either light or heat energy. We could represent light by the symbol H nu or heat with the symbol delta, so we can get used to seeing perhaps either of those reaction conditions. And the products we're going to get here will be CH3Cl, so chloromethane, and HCl. So you can see that we have halogenated the alkane. You replace one of the hydrogens on the alkane with a halogen. And this is a very important reaction because it's a way that we can functionalize an alkane and convert them into an alkyl halide. An alkyl halide is going to be very useful in organic synthesis. We can do lots of interesting reactions with alkyl halides. And alkanes are readily available through the distillation of our crude oil from a refinery. So we have a lot of alkanes as natural raw materials, and this would be a great reaction as a way to convert them to alkyl halides. So let's take a look at the mechanism of the free radical halogenation, and as the name implies, it's going to involve free radicals, and it's also an example of what's known as a chain reaction. And we're going to have two major steps that form the product. But before we can get to those two major steps, first we have to start the radical reaction, and that first step is called an initiation. Initiation step is one that creates radicals. And the way a radical is created in these reaction conditions is that the chlorine reacts with either the H nu or the heat, the light or the heat, and we're going to break the chlorine-chlorine bond homolytically. One electron is going to go to each side, and we're going to form two chlorine atoms. So that's going to be our very first step in the mechanism, is to create a radical. Once we have a radical started, now that radical is going to react with some other species. We'll take the chlorine and we'll react it with our alkane. What's going to happen is that chlorine is unstable, it's very reactive, and what radicals like to do is they like to pluck an atom off of another species. We call it an atom abstraction. So it's going to see this hydrogen, it's going to grab that hydrogen, one electron is going to pair up with the radical, and the other electron is going to stay behind. That's going to form a molecule of HCl, which we saw above is one of the products that we're expecting. And what else does it form? It forms a methyl radical. So this type of a radical mechanism step is called a propagation step because we're starting with one radical, and the product we get still has a radical in the product. So one radical gets converted to a new radical. We call those types of steps propagation steps. And we would describe this first step as a hydrogen atom abstraction. You abstracted or plucked off a hydrogen atom, a hydrogen with its one electrons, with its one electron. Now we have a methyl radical. What is that methyl radical going to want to do? Well, again, it's unstable. It wants to stabilize itself. It's going to look around for an atom to steal, and what it's going to find is a molecule of Cl2. So we're going to have the exactly analogous mechanism where the carbon plucks a chlorine atom off of Cl2. That leaves a radical behind. So the product we get here now has a carbon-chlorine bond. And we've just made our product. We've just formed a molecule of chloromethane. What else is formed in this step? We also form Cl dot, chlorine atom. And what can that chlorine atom do? That can continue back and attack another equivalent of the alkyl halide. Okay, so this will continue the radical mechanism. The chain reaction. So it's called a chain reaction because as soon as you form just one radical, these propagation steps will go on and on and on. These happen many times. And these are the two main steps I described in how to form your product is plucking off a hydrogen atom from the alkane, and then the resulting alkyl radical plucking off a chlorine from Cl2. We could describe the second step as a chlorine atom abstraction. So after our initiation step, all the steps of our free radical halogenation are propagation steps that are atom abstractions. Now, what else can happen in a radical reaction? Another thing that can happen